Hello everybody, my name is Esben Østrgaard, and one of the founders of a company called Universal Robots that had a lot of success. I've been part of a pretty crazy growth journey. So what I'm going to talk with you about is, the growth journey and the story behind that, but also, I've been philosophizing a little bit about why that happened, and that's what I'm going to share with you about this Industry 5.0 topic. So just a second, I need to be able to flip this. So the company I was part of founding was called Universal Robots, and it grew to around today it's around 1,000 people. I founded it in 2005. So I've been part of a super crazy growth journey. If you look at the numbers here, I mean, the company was founded in 2005. Last year, the turnover was $245 million. And if you look on the right side of the screen, you can see the number of employees have basically consistently doubled every year in the years from 2009 to roughly 2016 or so, with a pretty tremendous growth. And that was, of course, a pretty crazy growth journey for Universal Robots. And today it's the dominating, you can say, robot company in a new kind of robotics called collaborative robots. So my background, I have a super nerdy background. I have a PhD in robotics, and I did this crazy project on building transformer robots that could crawl around and connect to each other. And that's what I did in my PhD. And then I worked as a professor at the university after that. But we had a related project going on at the university, which was to try to figure out how we could make robots more productive and flexible in typical small and medium-sized companies, which had a need for flexibility. So we built this robot cell that you see in the picture here, which is we tried to make as flexible as possible and let these people working in this is a food factory, make them able to move the robot around and redeploy to do different tasks. But we found that with this technology, it was not possible to give these guys the flexibility they needed to perform the work they needed to get done. And so we could see a need for a new kind of robot that was more flexible and easy to use and easy to move around and so on. So based on that idea, we started the company, of course, like most other startups, in a garage type environment with a lot of mess and metal parts everywhere, and programming with oil up to both elbows. And after some time, we managed to actually get a pretty decent robot out of it after a lot of development. And in 2007, we had it out and testing it in a greenhouse where we did do some. You can say we knew that technology would work. We had it out there, we set it up in 4 hours, and it was actually doing the job of moving these pots of dirt as requested by the customer. So we could see that we had the right technology to actually deliver the type of robot that the world needed. But at the same time, we were completely out of money, and we had a tough time finding investors and convincing people that our robot was actually better than the other robots. In 2009, we managed to close. 2008, late 2008, we actually managed to close the deal with an investor, and you can say from that point, the company transitioned from being a garage type startup to being a more, let's say, professionally driven, commercially driven company. And when we went to the Automatica fair in Germany for the first time in 2010, we actually managed to get the front page of this newspaper, the Messe-Zeitung in Germany, which was super cool for a startup, of course, to come and get the front page, because our technology was something really new that the market hadn't seen before, and that was recognized by the industry straight away. And then since then, there were a lot of years where I got crazy amounts of awards, so met a lot of important people and showed them the robot. And I have I guess I can show that. I have a whole wall full of awards over next to my desk here. So a big thing was when we sold the company in 2015. We sold the company for $285 million plus $65 million earnout. So we actually sold it before it became a unicorn, but it would have been a unicorn today if it had been sold today, because it has grown since then. And we created a big thing. We created a global market, a $2 billion global market already next year with this new type of robot that we started. So some of the money I got out from selling Universal Robots, I invested in another company called Mir, which is the small white robot you see in front of the card here. and that company also became quite successful. And we sold that company in 2018 for $272 million. So that was another, you can say, huge success in robotics. And it's actually the same buyer that bought both Universal Robots and Mir. So both the companies I've been involved in that were sold. So what that has created in the city where I live in Odense in Denmark is, you could say now it's more like a whole ecosystem about, about robotics. So today there's more than 140 robot companies present in this small city where I live, and roughly 8,500 robot jobs and a pretty big revenue already in 2018. But this is projected to grow to 25,000 robot jobs here in 2025. So it has really started, you can say, a snowball of a lot of startups, a lot of money pouring in, a lot of talent, and so on. And everybody's on board, including the local government and the university and so forth. A lot of big players and a lot of small companies. So what was it we did? So what we did was we thought of a robot more like a tool to help people do their work rather than this big heavy machine that steals people's jobs. And that was the kind of the approach we had to robotics and what created this new market. So now, since I sold all these companies, I have some time to think about what actually happened. And that I'll just give you some a little bit philosophical thoughts. So what drives humanity forward, I would claim, is money, power, and love. And what is money? Money is value. You can say there's a tangible value and an intangible abstract value. Arguably, the intangible value is more real value, but the money is somehow representing the real value and is accountable, easy to measure the type of success criteria or reward mechanism. So what is power? The power is the ability to change the world, and you can divide it into three kinds of power. So there's a primary power, which was the type of power that was predominant, and you can say in the old age, in the Viking age, where the guy with the biggest sword, he had the power. And then power has changed as society matured into, you can say, secondary power, which is more about legal frameworks and money and that kind of thing, and also to, you can say, tertiary power, which is about ideas and how to affect the world through ideas and what you say. But all these things, you can say, are very motivating for humanity, money, power, and love. But in reality, it's not. Oh, I should say love also. I finally figured love out. So I figured out it's a fourth tuple. So you can have this sexual attraction, being needed and being needy, and then belonging and feeling at home. If you have those four, then it's love, and then you can experiment with different kinds of love depending on which of these elements are present. So I would argue true love is when all four elements are present. But this is all good and fine, but it actually doesn't move humanity forward. What moves us forward is technology. And when we started using technology to do our work more efficiently, and I couldn't find a picture of a Stone Age man actually digging out termites, so I had to go with a chimpanzee. But that actually transitioned, you could say, our species from being, using most of our time just getting food, to being able to do more things like build bigger, better nests, or have war with the neighboring monkeys. So our evolution is, to a large degree, not an evolution in biology. So in the beginning, our evolution was through biology, but since the invention of the advanced tools, then our evolution is actually done through technology rather than biology. So that's the trajectory that humankind is on right now. It's the technology that makes our lives different today than 200 years ago, and will make our lives different in 200 years. It is not our biology that's evolving anymore. So today is a evolution of tools and how we use tools to do more with our time and energy. And robots, and I'm sorry, I had a video here, I can't show that. So robots is part of that trajectory. So robotics was an idea that you could say is pretty old. We can build mechanical things. Oh, there should be a picture of Da Vinci's human there, but human statue. But when Da Vinci built his mechanical robot statue in 1495, he was not trying to build a factory worker. He was actually exploring what it is to be human and using technology to reflect humanity in some way. But in the 1950s, this technology became sufficiently advanced so it could be used in manufacturing. And that's actually where the industrial robot started popping up all over the world near the automotive factories. And what we know from robotics is it's coming from this kind of automotive industry, high volume, high throughput kind of environment, and it's slowly growing out of that environment to other adjacent environments such as hospitals, construction sites, and food and logistics, and so on. And also to the small and medium-sized companies, and probably in the future we'll have robots in the home and doing domestic service. So there's a clear trajectory for the technology, which is going from volume manufacturing and high throughput to, you can say, what in the left side here, the robots are doing the same thing every time, every day, 7 years in a row. In the right side here, robots are never doing the same motion twice. They're all the time reacting to the task and the environment and the presence of humans. So there's a clear, you could say, shift in where robotics is going, or clear direction in where robotics is going. And safety is also a big part of this. So in the left side here, these machines are totally unsafe. If you walk in there, you would probably be killed in a short time. In the right side, robots are not allowed to kill or harm people. So there's a lot of safety also in this evolution, but flexibility is also a key. Robots have to adapt and be task driven and have individual tasks and figure out new ways to solve things all the time in the future. And this goes pretty much hand in hand with these famous 4 industrial revolutions we've been through so far. So mechanization of agriculture freed up a huge percentage of the workforce to do other things than just providing food for themselves. They moved to the cities, created the second industrial revolution where we had mass production and electrification of manufacturing. Then we have the third industrial revolution. And in this, we started to see robotics and computer-controlled automation, and then today we have the fourth industrial revolution, which is data-driven and about how we use data to create more value. And the point of my talk is that there's a gap missing in this slide. So what happens after this? So I would argue that the key to the future is to bring back some of more of this human passion and knowledge into the manufacturing and how we create value. So we already see mass customization as a driver. So you can no longer, you don't want the same doormat as your neighbor. You cannot have normal salt. You need a Himalayan something salt and a microbrewed beer. So we all like to have mass customized products, and we also see now a reshoring wave, probably especially from this coronavirus, where we start moving manufacturing back towards the consumers, or local manufacturing is becoming a thing. So we are moving away from this kind of manufacturing environment where you dream about a lights out factory, but what you get is you can say a line full of people working like robots. That mentality is probably on the way out, because you're missing something crucial here, which is the value, you can say the love and the passion that the consumers are willing to pay a premium for. And that goes back to, you know, say the way of thinking manufacturing from the old days, which by the way is also how we have shaped our school system today. So it's like a sausage factory. It's not probably not the thing that will create the most value in the future, because in that time the schools were educating people to come out and work like this. So this is not a production factory, but you can say this is a white collar factory, an idea factory. And the word processor, of course, replaced a lot of these people's work. So when Bill Gates introduced the word processor, Microsoft Word, he replaced a lot of these people, but office work as such has not disappeared. But it means that the CEO can now write his own letter. He doesn't need to have a typewriting pool of women doing the typewriting, but he's, you could say, free to do other things. And in general, there's more office work today than there were when the typewriter was replaced by the word processor. So there's a point here that work is not disappearing, but jobs are getting disrupted. And you can look here in this McKinsey study and see what studies are getting disrupted the most, what jobs are getting disrupted the most. Some jobs have a higher, some work have a higher content of jobs that can get automated, and some have less, but all jobs have some automation potential. And that's the key. But back to what drives us, we all want to be special, and this feeling special is what's driving, I would say, this Industry 5.0, which is about adding human touch back to manufacturing and mixing, you can say, the human ingenuity with machines to create the best possible value. And it's also moving more power back to the production floor, where we're not dreaming about lights out factories anymore. We're now dreaming about you can say mixing robots and people, and these people working on the shop floor, they're using their knowledge to the fullest when creating products. And studies show that this combination is actually more productive than one or the other. So there's been some studies on that, and so it's not just me babbling away. So I mean, I've sold some companies, and I have enough money now, but what to do? So I decided to try to help the world and looking at these sustainable development goals. And together with my wife, I've started a company that reinvests in a better future through robotics. Actually, we analyzed these goals, and we found out education is probably the best way to help the world. But since we don't know anything about education, but only know something about robotics, we have decided to do what we can through robotics. And what we have done now is we have invested in a number of companies that help the world by robots. So that's organic farming robots or education robots, or we actually also have a robot for coronavirus testing that we are trying to push to the market. So my bottom line is we shouldn't think about man against the machine, man or machine, but it's this combination of man and machine that creates a better world, and that is what has pushed human to where we are today. So I think, thank you. I'm 1 minute over. Thanks a lot. I'll do typing. So regarding humans and in production line, so I have an example where there's a loudspeaker factory that produces high quality loudspeakers, and there's a woman polishing it and making sure that the speakers look really good when they go to the customer. In that factory, we put in a robot to help her do the polishing, but the robot has no clue what good quality looks like. It doesn't know what the customers want in the end. So we still need that woman there who has her years of experience on doing the right polishing to do the finish, but she can easily instruct the robot to do the big parts of the surface and so on. So there are some things humans are much better at than robots, but there are some things that robots do better, such as repetitive tasks and so on. And there's no value in this woman doing the big, boring, rough grinding or polishing of the speakers. And we've seen that so many places. There's a lot of pride in people getting a robot to do the boring part of their work, but they kind of keep their craftsmanship. So that's what I'm trying to say here. It's actually that combination of man and machine that creates the most value in the future. And I would argue this is what has brought us to where we are today as a species, basically controlling the fate of the planet right now. So, regarding sharing, I think that's part of the deal here in this UPPSTART conference. You can buy the content later. And thanks for all the nice comments. So the biggest obstacle for SME manufacturers to incorporate robotics, there is a little bit of, say upfront cost. That it is an investment to start using robots, and that's of course a challenge. And then the other challenge is the knowledge about robotics, that they don't know what's possible and what's not possible. But what we have seen in Universal Robots and also in MIR is that when people start using robots, they actually end up getting more robots, but at the same time they hire more people. And that's a little bit counterintuitive, but the reason is, of course, that their business starts growing, and that means that they get more profitable and they get more work, and they basically need more robots and more people at the same time. So I think the obstacle is just how to get started with robots, and that's the trick. Yeah, this robots cobot as a service. In mature industries such as the forklift industry, all forklifts are rented out as leased or something like that. But in robotics, normally not. And of course, one of the reasons is there is a lot of upfront cost in installing the robot. So it's not very cheap to just drop in a robot because there is some integration work that's required to set in the robot into a factory line, and that cannot be, you can say, easily recuperated in case the customer decides to change it after 1 month or something like that. So it's a little bit difficult to use a service model for factory robots. But on the other hand, most industries that become very mature, they start having these leasing models or service models. So it probably might happen at some point, but it's a little bit far away right now. And regarding the safety, yes, so safety is a big thing. And I was part of writing this current safety standard called TS 15066. I was sitting in that committee. And it's not super easy to make a good standard for what is safe and not. But there is one now, and it does work. I mean, it is possible to make safe installations within the framework of the standards that are currently valid. I don't think the standards are great. They're actually, I think, very, very conservative, and I think it's also a matter of common sense. If yes, 50, I was part of writing 15066, and I'm of course an expert in 10 to 18. And they are like the standard, but the problem is it's very hard to know what an injury is and what pain is acceptable in factory. I mean, you can get your finger stuck in a door, fall down the stairs, or get hit on the parking lot, which is actually a big problem in many factories. That the accidents happen on the parking lot. The problem is it's very hard to do tests on humans that are legally acceptable if you're trying to injure them. There are no good tests on injury levels. There are a lot of tests on pain levels because that's legal to do those tests, but you cannot test injury levels. So actually nobody really knows what the acceptable impact forces and so on are. But it all boils down to common sense. If when you start to feel, oh, that's awful, they change the values in TS 15066. That's not nice. I didn't know that. So they made them even more conservative. I thought they were too conservative already. But the good thing is it's all based on common sense in the end, that if you can see it's safe, then it's okay. The risk assessment you have to make is basically common sense, so it's not as bad as it sounds. If it's okay, it's okay. If it's not okay, it's not okay. I mean, if you can get injured, it's not acceptable. But if it's moving slowly and everything is rounded and the robot will stop at a certain force, then there is no problem actually. Or you can add safety devices such as light curtains and so on to make it more safe. You can also have light curtains that when you break the light curtain, the robot goes slower and then it speeds up again when you move away. Yes, I was engaged in TS 15066, but not for the last 2 years. So I haven't been there recently. I sold Universal Robots in 2000. We sold Universal Robots in 2015, and since then I've been working there, but you can say phasing out. And I haven't worked there the last 1.5 years. So remote control robot. Sorry, my microphone just turned off. Yeah, I mean, this whole robot safety standard is regarding your comment, Claes, it's a tough fight, but I think it's worth fighting it. Of course, the health and safety organizations are super worried about it, and but on the other hand, if everything moves to other countries where they don't care, then all jobs will disappear and so on, and that's also bad. People will lose, their jobs, and that's also not healthy for them. So there's a balance between acceptable and safe and all that. And regarding remote controlled robots, I mean, yes, it makes sense, of course, to have remote controlled robots, but it will not. A lot of the business case will, of course, go away if you need to have a highly skilled operator controlling a robot. Then it only makes sense in those cases where it's super expensive to send the operator into the dangerous environment, or the robot can do something superhuman. And you can say exoskeletons are an example of these superhuman capabilities that are kind of remote controlled. But yeah, I think autonomous robots is, of course, the way forward. I mean, autonomous robots, yes.